Okay, so now what I want you to do, before you watch this, just pause it for a second. I want you to circle the tables and equations that represent linear functions right here, okay? So, pause me. Okay, are you done pausing me? Really? Did you pause? I don't know if you did. Well, I'm going to tell you which ones are linear by looking at. I'm going to give you some ideas of how to double check or see this. Let's start looking at this one. Let's see if this one's linear or not. Well, what you want to look for to see if it's linear is you want to see is the ratio between the y and the x always the same between 2 points. So see how it changes from 10 to 22. So that was a change of 12, and this was a change of 1. So that would be a ratio of 12 over 1. Okay. And from here from 22 to 34 is 12, and from here to here is 1. Again, that's a ratio of 12 to 1. Okay, so those are the same, right? And from 34 to 46, that's a change of 12, and this one is a change of 1. So again, 12 to 1 ratio. So this would represent a linear equation right there, because the ratios are all the same. Okay, so that's that one. That's the table. Let's go look at this table and see what happens. Here we go 3, 4, 5, 6. Those are all changes of 1, right? And here we got negative 5 to 1, that's a change of 6, and then here's a change of 5, and here's a change of 5 again. Did I do that right? Yeah, negative 5 to 1. So is this linear? No, it's not, because this is a ratio of 6 to 1, where this is 5 to 1, and this one is 5 to 1. So this one would not be linear. You can cross that one out. It's not linear. Okay? Now let's look at this table right here. So here we have a change of 3, here's a change of 3, and here's a change of 3. And here we got from negative 5 to negative 1, so that's an addition of 4, right? And from negative 1 to 3 is another addition of 4 and addition of 4. So it looks like we have a consistent ratio of 4 to 3. And because it's consistent, they're always the same, this one would be linear. Okay? So that's how you can tell by looking at a table. Let's take a look at see which of these equations are linear, because we know what graphs are linear, they're straight lines. Which of these equations are linear? Well, here's the thing you want to look for. Things you want to make sure aren't there. First thing you want to make sure isn't there is you want to make sure an x squared, or an x to the third, or an x to the fourth, anything to a power, that's going to make things not linear anymore. So this one is not linear, okay? The next thing you want to look for is to make sure all x's are actually not in a denominator. There's no x's in a denominator, okay? Or in a fraction in the denominator of a fraction. Fractions are okay, but in the denominator. So when we look at this one, see how this x is in the denominator? That's going to make it contort this graph a little, make it look really weird. It kind of looks something like this or like that, depending on the situation. So this one is not linear, okay? So what you're kind of looking for is polynomials, where you got an x to always to the 1 power, even though you don't see that 1, and you got some type of coefficient in front. So here we got a linear one. Here, this is a decimal. It doesn't really matter. Decimal, you can have decimals in linear functions. This one's linear. You got an x is to the 1 power. It's not in the denominator. There's no squares, no thirds. Here we got a negative x. Does that make it not linear? No, that's fine too. Here we go. This one's linear as well. Okay? So that's how you can tell by looking at a table or an equation if a function is linear or not. Now, in this summary, what I want you to do is, I want you to state, how can you tell when equation, line, and table represents a linear function? Now that you've gone through this lesson, you should be able to answer this question right here. When you're done with that, I got a few questions at the end, a higher order thinking question, and something just to summarize it. The summary, you can write here, and you can write on a line if you want to, or you can just write it on here, whichever you prefer. Okay. Well, I hope this first lesson went well for everyone, and I hope I can get some things tweaked and make these a lot better, but I hope these things work well. I'll see you in class tomorrow.